Hi everyone, in this video we are going to discuss the Earth's energy balance. So most of you, or maybe some of you, are familiar with the First Law of Thermodynamics, and in the First Law of Thermodynamics all it says is that the amount of energy we have in the universe is finite. So we cannot create energy and we cannot destroy energy. So what that really means is all of the energy that we receive from the sun in terms of UV, visible, and IR radiation, we have to then take that energy and release it back out into the atmosphere, or we emit it, and most of the time we admit it in terms of IR radiation. And so what we're going to do in this video is talk about that beautiful cycle about how we receive energy from the sun and then we release it back into the atmosphere. But in order to do that, we need to understand what's really unique about Earth and actually Venus too. So let's start off by looking at the sun. So we have our sun here. We'll give it a little spikes, make it look really cute and pretty. Okay, that's good enough. All right, so now next planet is Mercury. It's really small. Okay, the next one is Venus. We are next, so obviously that one's my favorite. We have Earth. And the last one is Mars. Obviously there's more this way, but I don't care about them. Okay, so sun. What we need to look at first is the expected temperature of these planets versus the actual temperature. So we're going to start with Mercury, and so we would expect for Mercury to have the hottest temperature, the largest temperature, just because it is closest to the sun. So it is going to receive the most amount of energy from the sun just simply by distance. Now for Mercury, we would actually expect it to have a temperature of 420 degrees Celsius. So everything here in my little chart is going to be in degrees Celsius. So we would expect it to be 427. It actually is 427. So Mercury is a perfect example. Now we go to Venus. For Venus, it's a little bit further from the sun, so we think it would be a little bit colder. So we would expect it to be about 100 degrees Celsius, the temperature at which water boils. Now, for Venus, the actual temperature is 450 degrees Celsius. 450 degrees! That's really, really hot. So something bizarre is happening on Venus. Let's go to Earth. For Earth, our distance actually would give us an expected temperature of negative 18 degrees Celsius. Thank goodness that's not our real temperature. We actually live at about 15 degrees Celsius. And based on your location, that's obviously going to change. This is a global average. Then we move to Mars. Mars has an expected temp of negative 50, and it actually is negative 50. So what we see is that for Venus and Earth, there's something really unique or cool about the planet that makes them have a significant difference in temperature or global temperature. And so what it turns out is that both of these planets have what's called atmospheres. Now, we've talked about atmosphere before, but just in case we've kind of lost our definition, let's review. It essentially is a layer of gases that exists above the ground of that planet. And so for Earth, we have three different layers, okay? We have a lower layer, we have a middle layer, and we have an upper layer. And I want to actually review here and see what you remember. So let's take a second and try to recall what the names are of our three different atmospheres. Go. All right, did we get an answer? Hopefully we did. So let's review just to make sure we're all on the same page. Our lower atmosphere is called the troposphere. Our middle atmosphere is called the stratosphere. And our upper atmosphere is called the mesosphere. Yes, you need to know all three of those. Now, Earth's atmosphere is wonderful because it traps IR radiation and keeps our planet warm, and it's actually a place where we can survive and live here. So what we need to do now is talk about the Earth's energy balance. So we're going to start off by looking at the sun, and then we're going to break this into two different categories. So we have our atmosphere right here. So ATM is an abbreviation for atmosphere, and we're going to say that's the uppermost part of our atmosphere. And then we're going to go all the way down here on the bottom, and we're going to say this is Earth, or this is Earth's surface. So now we are going to say that the sun emits radiation here to Earth, and it hits our atmosphere. And at this point, four different things can happen. But let me review something first. So we're saying 100% of the energy from the sun that hits Earth is emitted to us in forms of UV, so ultraviolet, visible, or IR, infrared. Now, these four different things can happen. So we're going to start here. The first thing is that it can be absorbed by our atmosphere. So we kind of draw it like this. So it never actually hits the Earth's surface. So we'll say absorbed, ABS, absorbed by, and then ATM, atmosphere. Now, this is in terms of 23%. So of that 100% that came here, 23% of it is absorbed by our atmosphere. Now, the next part goes all the way down our next part goes all the way down to the Earth right here, and that is in 46%. So 46% of the total energy from the sun comes down to the Earth, and this is actually absorbed, ABS, by Earth, or our Earth's surface. Now, also, the sun's energy could be reflected. And so we're going to go to the same part here. And so the first thing that we see is that it can actually be reflected by the atmosphere. So it's all the way out. That happens in 25% of the sun's total energy. So this is reflected by the atmosphere. And then the last thing that can happen is this can actually go all the way down. Let me see if I can get here. All the way down here. It hits the Earth and it's reflected by the Earth's surface, and it goes all the way out. So this is reflected by Earth. And when I say Earth, remember it's Earth's surface. And this actually only happens in about 6%. So this is probably the lowest one. Well, it is the lowest one that comes all the way in, hits the surface, and is reflected out. So let's see if we understand this drawing. And so my question that I want to pose to you is, how much of the sun's energy is absorbed? Go. Did we get an answer? Hopefully we did. And so all I was asking for was the amount of energy that was absorbed. So you were just looking for the two pieces here that said ABS. So we wanted to do 46 plus 23. And if you added that up correctly, you should have had something at about 69% energy. I could have also said how much was reflected, and you simply would have said 6 plus 25, which gives us 31%. All right, so let's move on. So that basically is a full description of what happens to the energy that we receive from the sun. Now my question is, what happens with the energy once it's here on Earth? And so we need to do the same thing as before. We need to draw a little diagram. So here at the top is our atmosphere. So here's ATM. And then below it, we are going to say we have Earth. Now, this is the energy that is starting from Earth. So we're going to start right here at the Earth's surface. So the first section I want to talk about is the energy that is emitted all the way out through the atmosphere. So this is the energy that is emitted by Earth. And remember, when I say Earth, I mean Earth's surface. This only happens in 9%. So not a lot, but some of the energy is emitted from Earth all the way out through the atmosphere, 9%. Now, when I talk about the energy that is emitted from Earth in general, it is all IR radiation. It's all infrared. So remember, the sun gave us energy in forms of UV, Vis, and IR. The Earth only emits in terms of IR. Now, the next section that we have is it emits to the atmosphere. And so we say that this part is absorbed by the atmosphere. And that happens at about 37%. Okay? But the most of our energy that is released away from our planet is actually done by our atmosphere. So we could come over here and start a whole new dot right here and say this energy is released all the way out. And so this would be emitted by our atmosphere. And that actually happens in 60%. So that's our most amount of energy that is released from our planet back out into the galaxy. So let's make sure we understand this fully. And I want to pose one question that has to do with both of the diagrams. So is the radiation emitted by Earth higher or lower in energy, okay, so we're being specific here, in energy, than the radiation emitted by the sun? Good luck. All right, did we get an answer? Hopefully we did. I hope you said lower, because that is absolutely the correct answer. And here's all you had to do to figure that out. The Earth emits energy in forms of IR, where the sun emits energy in terms of UV, Vis, and IR. So this energy right here is very, very high energy, but it's considered low wavelength, okay? Whereas IR is considered very, very low energy, but it has a high wavelength. Hopefully that makes sense. Take care of yourselves, guys.